A subgrade's performance generally depends on two interrelated characteristics. Load-bearing capacity. The subgrade must be able to support loads transmitted from the pavement structure. This load-bearing capacity is often affected by degree of compaction, moisture content, and soil type. A subgrade that can support a high amount of loading without excessive deformation is considered good. Volume changes. Most soils undergo some amount of volume change when exposed to excessive moisture or freezing conditions. Some clay soils shrink and swell depending upon their moisture content, while soils with excessive fines may be susceptible to frost heave in freezing areas. Ash, especially on the Big Island, can present volume change problems. Poor subgrade should be avoided if possible, but when it is necessary to build over weak soils, there are several methods used to improve subgrade performance: removal and replacement over excavation. Poor subgrade soil can simply be removed and replaced with higher quality fill. Although this is simple in concept, it can in short. A thick pavement structure over a poor subgrade may not make a good pavement. Subgrade physical properties. Subgrade materials are typically characterized by 1. Their resistance to deformation under load. In other words, their stiffness or to their bearing capacity. In other words, their strength. In general, the more resistant to deformation a subgrade is, the more load it can support before reaching a critical deformation value. Although there are others shrink as well in the case of certain clays and ash. Stiffness is the most common characterization. There are 3 basic subgrade stiffness or strength characterizations commonly used in the U.S. California bearing ratio (CBR), a simple test that compares the bearing capacity of a material with that of a well-graded crushed stone. Thus, a high-quality crushed stone material should have a CBR of about 100%. CBR is basically a measure of strength. It is primarily intended for, but not limited to, evaluating the strength of non-stabilized cohesive materials. Having maximum agency and commercial geotechnical laboratories in the U.S. are equipped to perform CBR tests. Resistance value or value, stabilometer, and is identical to the one used in HMA mixed design. The OR value is basically a measure of stiffness. Resilient modulus MR, a test used to estimate elastic modulus, a material's stress-strain relationship. The resilient modulus test applies a repeated axial cyclic stress of fixed magnitude, load duration, and cycle duration to a cylindrical test specimen. While the specimen is subjected to this dynamic cyclic stress, it is also subjected to a static confining stress provided by a triaxial pressure chamber. It is essentially a cyclic version of a triaxial compression test. The cyclic load application is thought to more accurately simulate actual traffic loading. Resilient modulus is basically a measure of stiffness.